Tales from the trenches. Stories forged in the fires of experience. This episode recorded live at the 2024 National HVACR Education Conference. Learn more about the education conference at escogroup.org. All right, everybody, thank you so much for joining us once again on Did You Know the ESCO HVAC podcast. So we're spending time here at the National HVACR Education Conference, and we are going to spend a little bit of time diving into some ECM troubleshooting, and we're going to set you up for a class that we're going to have with Chris Mohalley here. Yay! And I encourage everyone to hop in and take a look at it. We'll cue you in for some pre-recorded classes that we had that Chris and I did covering a variety of ECM topics and the evolution, but we wanted to spend a little bit of time just bringing some awareness to changes that we've seen in the industry. So welcome, guys. Glad to have you all. Introduce yourselves as we go through, and let's dive on in.
My name's Dirk Nauman. I'm with HVAC Simulator and enjoying the HVAC excellence.
Hey, I'm Jim Fultz with Copeland White Rogers. Great show. Appreciate everything Clifton and the team's putting on here.
Chris Mohalley with Regal Rexnord, supporting the brand Gentech Motors.
All right, guys. So a question got brought up amongst yourselves, and let's dive a little bit deeper and kind of explore some of the interests you had.
All right. Well, I'll start. Just a little bit of history behind how the three of us are together here at a podcast. About a year and a half ago, White Rogers created a universal board that would do both PSC motors as well as ECMX or X13s. And it's been a really good board. Was sharing it with Dirk and saying, hey, that would be a great addition to the HVAC simulator.
Absolutely, yeah.
And so we got together and I sent him a board, and I'm going to pass the mic over to him to let him share what happened next.
Yeah, so in the creation of the HVAC Simulator with the universal board, I put the board on, wrote the program, and then it doesn't work. So I'm sitting there with my meter trying to figure it out, and I'm like, this board does not work. I send a email to Jim, and I say, Jim, what'd you send me here? Did you send me a lemon? What is this? And so I can't figure this out. So then I sent it to Jim, and he talked to his engineers and said, hey, it's not working. The engineer said, did you put it on a real furnace? And I was like, all right, here we go. And the answer was no. I put it on the real furnace, and it worked. I'm just like, all right, what's going on here? I found out that ECM motors, X13 constant torque ECM motors, they accept a 10 volt DC. My meter was set to 24 volt AC because my mindset was the control signal is always 24 volt AC. So the logic here is if you don't know how something works, you cannot fix it. So I was not able to fix it. So I'm going to pass it to Chris. Actually, before that, so I got the ECM motor out, or I pulled out the Gentech tech guide, and I started looking at, and there's a one-liner in there that says accepts 10 volts DC.
Yes.
So, yeah. Chris. Well, I'm just going to clean up a couple of things because this is not, I mean, you're recording, but some people might be listening. So when we say X13, we haven't made X13 for a little while. The names have changed, but we're talking about constant torque ECM motors, most identifiable by the 9-pin plug. Usually says CLGN across the top of the plug, 1, 2, 3, 4, 5 across the bottom. It'll make it easier for everyone to associate that motor. We're also not the only ones that make it. But everyone's using that same identifiable 9-pin plug. Yeah. So that's the motor we're talking about. And as you said, traditionally it's been built, and still today is most widely built with 24 volt speed taps. For 24 volts, it taps 1 through 5. Motor changes speeds based on how the manufacturer programmed it. So here's some of the hiccups. One, the outside of the motor has not changed. Nothing about the way the motor looks has changed. So we've offered it in PWM mode. We now offer it in what's called a 9-speed mode. And both of those modes of operation use DC voltage to energize the taps, 1 through 5, or just tap 1 for PWM. Now, again, so if the technician is just looking at the motor, there's nothing identifiable about the motor. In your case, you got kind of set up on this. In your case, you were just given a motor. There's all that programming change happens inside the motor and the microprocessor. There's no way for you to know what that motor's looking to accept. But and another challenge, and this is kind of a great topic because I'm talking about it today.
That's right.
And we just recorded it, like you said. But technicians think that these motors don't change. Right? They learn one thing and okay, I'll just apply that.
I know this plug. I know what this is.
Right, and I'll just apply that forever. And I don't want to, oh my God, the simplest motor just changed. Oh, the world's coming to an end. So I would say 75 to 80% of these motors that are still being used by OEMs today are still used with 24 volt speed taps.
Right.
It's
AC.
24 volts AC speed taps. Yes. So it is a small amount of OEMs that have chosen to use the PWM or the 9-speed motor, and they're doing that so that they can reduce SKUs, right? One motor has a wider breadth of operating range, so they can handle a wider unit range with it. But so really what happened is 5-10 years ago, we started offering PWM first. And PWM signal is based off of a DC voltage, creating a square wave.
Which stands for?
Pulse width modulation. Thank you very much, Jim. So, 3 years ago, we started offering 9-speed mode, and that uses all 5 pins, but it's using DC voltage as well. So here's the easiest way, and I think this is probably of the most value for the people that are listening, the technicians in the field. If you see the constant torque motor wired back to the board, and at the board, those wires are landing on heat, cool, and fan, it's almost 100% going to be a 24 volt AC controlled motor with multiple speed taps programmed into the motor. If you see that all 5 of those taps on the motor brought back to the OEM board, plug to plug, there's no heat, cool, fan taps, that's your clue. Something's going on here. Better get in the book, find out if we're using DC voltage. For PWM, so we only do PWM on pin 1. It's numbered number 1 right on the motor. So if you see one wire in pin 1, again, going straight back to the board with plug to plug, no heat, cool, fan.
Absolutely.
PWM,
DC
probably
voltage.
PWM, yeah. Right. And I'll just say one more thing, because I've been talking too long and somebody else should get in. In the PWM mode, we also do it where the OEM can get some feedback information. So even though they're only using pin 1 to operate the motor, there may be 2 other pins powered. On our motors, likely 4 and 5, where they're powering 4 and 5 is sending some information back to their board. And so one last thing, I know I said it'd be done. So now these constant torque motors operate and they adjust as far as airflow adjustments, very similar to the variable speed motors, which have been around forever and most contractors are familiar with, right? So I'm going to make no adjustments on these DC controlled motors at the motor. I'm going to be adjusting dip switches. And I'm going to need to go into the manual to find out the diagnostic values, which will typically be DC at the motor.
Based on the OEM programming, because it could be a variety of different voltage positions or ranges depending on where it was designed at.
It actually could be. It could be a 9-volt value or an 18-volt value. It could be somewhere in between, because we give the manufacturers, engineering latitude to choose how they want to control the motor.
Yeah, it makes complete sense.
So we can back up here a little bit to where I think both of Dirk and I were, and that was when we were teaching the constant torque motor, we was saying, okay, we have 120 going in, which is actually going to be converted to DC 3-phase back to AC 3-phase for the motor. And the motor itself is just simply a 3-phase AC motor. And for the ECM or constant torque, that motor, for me to get my mind around it, I was like, it's no different than an air conditioning condenser. You have 220 going to the condenser, but it takes 24 volts to pull the contactor down for that compressor and fan motor to run. And that's exactly what's happening with a constant torque motor. You have the 110 going in, which is going to be converted through that head, but you have a low voltage, and historically it was 24 volts going into this thing. And depending on which tap you sent that 24 volts in, that contactor pulled in the motor and chose that speed. And so this was a revelation, I think, to all of us that, hey, we have different voltages here.
Yeah.
And especially for us, after we've created a universal board and the technicians are like, hey, I don't have 24 volts here. Something's not right.
Yeah.
Well, so even if it only has 3 taps being powered on the motor, if they're using some boards like our aftermarket board, they're still not going to get that 24 volts off of it. It's going to be a DC signal, and that range, I would agree with you for the testing that we done. It was like, hey, there's a range here that we can be in. It's not just 10 volt DC. It can be above and below that. So
it's not a unified standard.
Correct. So let's get Dirk back in here to finish how he's summed things up.
Yeah, so as a technician and a technical trainer for the Habager Corporation, ECM motors is the kind of like the topic that draws people into training because they don't understand them. Again, I want to stress the importance. If you do not know how something works, you cannot diagnose it. It's that simple. And I met Chris, I don't know if you remember this, in Tucson, Arizona at the RSES convention in 2010. Yeah. And with that, Chris talked about the ECM motors, and they were out for a while, but that's when about around the 2010 era is when you started seeing more and more of them. And Chris had a 3-part series, ECM 1, 2, and 3.
Yeah, with RSES.
Yes, with RSES and the SAM manuals.
Yep.
And then with that, I want to put a plug in for the website. And the website, the name's like this long. I have it copied into my training for people to click, but ECM University,
Master University.
Thank you. But if technicians would go there and they would spend 1 hour watching these videos, they would be the expert in their company on ECM motors. So I'm putting a plug in. Chris, do you know that website?
That is regalmmu.com, and it is called the Motor Master University. Thank you, Clifton.
Absolutely.
I'll turn it over to you, Clifton.
Yeah, no, this is great. And you're going to see some videos, some podcasts with Chris and I on that exact same site where we dive deeper into this, and we actually do some visual representation of it. We have a little fun. We have a lot of fun.
We have a lot of fun.
It is a lot of fun. You know, I mean, are you kidding? I mean, this is a fun group right here,
you
right?
Betcha.
You know, you're getting the top of the industry talking about things that are happening in this world, and so we try to encourage you all to understand the things that we work with on a daily basis, to be able to look at things and see that, you know, sometimes things change and we may not be aware of it. And it's up to us to continually educate ourselves. We have 1,200 of us here that are all for the same reason, to educate ourselves, to make sure that we're delivering the proper content back to our classrooms, back to our technicians, and just getting better at the things that we do.
You bet.
Cool.
So the takeaway that I'd like to summarize for myself here is, when you're troubleshooting a constant torque motor, don't count on a 24-volt signal from the board to the motor. It may be there, it may not be there, depending on the manufacturer, depending on what board it is. And if you're not getting 24 volts, switch your meter to DC, check it in DC, see if you're getting somewhere to 9 to 18 volts, somewhere in there, and check it that way, because it may be that the signal that's communicating is now a DC signal and not an AC. And if you're not checking that, as well as what we would have traditionally known as the 24-volt AC signal, you may be missing what actually is going on with the equipment. So,
can I get an RTFM, please?
What's that saying for?
I missed it.
Read the
fantastic manual.
Read the fun manual.
Oh, it's not full? Oh, it's a fantastic, fun,
It's
full
fabulous.
manual.
I think that's what I heard. Maybe it's a fun manual. Absolutely. Read your installation manual. Clarify what those signals actually are being used for.
You got it.
Cool. All right, guys. Thanks for joining me.
Thank you.
Our pleasure.